So let's say you're going to have a track race here. You have this big 300-pound lineman. He's one of the runners, and the other one's going to be one of those small running backs. Who do you think's going to win? 100-yard dash. All right, yep. 99.9999% of the time, meaning all the time, running back's going to win. Why? Because that guy is typically a lot smaller, weighs a little bit less than your 300-pound offensive lineman. As a former offensive lineman who ran track, I can attest to that is true 100%. So, this happened the same thing with gases. The scientist Graham said that a heavier gas moves slower, or it'll slower travel over a given distance versus a lighter gas. And he came up with this equation, and this is called the Grahms Law equation. So this is called a ratio of rates. All right, so the ratio of rates of the speed of the two gases, they are inversely proportional to the square root of the molar masses. All right, so what that means is this equation right here. R1 over R2. Now that is a ratio of rates. That typically means, and you know how ratios work, it's like 2 to 1 or 5 to 1. It can even be like 4.5 to 1. Just means how many times faster gas 1 is versus gas 2. So that's your ratio. So if they ask for the ratio of rates, you're looking essentially for that fraction there. All right, so that equals the square root of M. Now remember, capital M, just like in density, capital M is the molar mass of gas 2 over the molar mass of gas 1. Now, make sure you note R2 and M2. R1 and M1. They're the inverse. You're on opposite sides there. All right, so let's do some examples with this equation. So we're going to find the ratio rates of the velocities of carbon dioxide and methane. All right, so carbon dioxide, remember carbon dioxide is CO2. Hopefully you guys knew that, you should have. And methane. So our molar mass for CO2, all right, we'll type this in your calculator. Carbon is, let's write it over here. Carbon is 12.01 grams per mole. Oxygen, 16 grams per mole. And for CH4, hydrogen, 1.01 grams per mole. Okay, so molar mass for carbon, if you add those up, comes out to 44.01 grams per mole. And CH4, that comes out to 16.05 grams per mole. All right, so we're going to use our equation. Remember, R1, R2 equals M2 over M1. All right, now I say, with a little hint here, use the heavier gas as gas 2. All right, what we're going to do is we'll do them both ways so you see the answers. And see how, even though they're different answers, how they're essentially mean the same thing. All right, so we're going to do the heavier gas as gas 2. So that's going to be this one. So this one's number 2. This one's number 1. All right. So R1 over R2, square root of the molar mass of gas 2, which is 44.01 over the molar mass of CH4, which is 16.05. And this is, grams per mole, grams per mole. Okay. Now, those units are going to cancel out. Ratios do not have units, so it's just going to be a number. So that's okay. Set up right. All right, so do 44.01 divided by 16.05. Now, if you do that, you get the square root of, divide those two, you get the square root of 2.74. If you take the square root of that, you get 1.65. Okay, that's your ratio. That's R1 over R2. Say, but wait, that's only got one number. Yeah, well, technically, it's that 1.65 over 1. All right. So the way we read that is, remember which one's the fastest? Yes, CH4. So we say methane, or CH4, is 1.65 times faster than CO2, than carbon dioxide. So that's a ratio, 1.65 times to 1 time. All right, or if you have a set amount of time, all right, however long it takes for CH4 to go 1.65 meters, CO2 will travel just 1 meter. So that's your ratio of rates. All right. So now that's what we have. The heavier gas is gas 2. We're going to make the heavier gas gas 1 this time. Okay. So instead of CO2 being on top, we're going to put CH4. So we're going to have 16.05 over 44.01. All right. So if you do that, do 16.05 divided by 44.01. All right, that gets you 0.365. We'll round up here. All right, let's take a square root of that. You get 0.604. All right, two different answers, yes. All right, but if you look at this, R1, when we on the left side here, we said R1 was gas 1, so we designated it as CH4. So you say gas 1, CH4, is 1.65 times faster. So if we kind of state it the same way with this, well, R1 here is CO2. CO2 is 0.604 times as fast, which is less than 1, though it means it's technically slower, as CH4. So they're both correct answers. The one on the left makes a little more sense in how we usually explain things, but if you did it either way, you get either one of those answers. Technically, you're correct when you're looking for the ratio of rates. All right, a couple of examples we can do with this. Oxygen gas is 1.618 times faster than a certain noble gas. So we're going to find the certain noble gas. All right. So if oxygen's 1.618 times faster, is oxygen the lighter gas or the heavier gas? Okay, well, it's faster, so that means it's the lighter gas. Remember, we want the heavier gases to be gas 2. Okay, so say gas 1 is going to be oxygen. Remember, it's O2, so it's oxygen gas. Gas 2, it's going to be X, the unknown. All right, so let's calculate this out. R1 over R2 equals square root of M2 over M1. All right, so R1, 1.618 over R2, which is 1. Molar mass 2, we don't know, we're trying to find that. Over M1, which is oxygen. All right, now remember it's oxygen's O2, which is 32. All right, so use your math knowledge. How do we do that? What's the next step? If you said square both sides, you're correct. And I'm sure everybody said square both sides because you all are smart. So we're going to square both sides. Because on the right side, if you take this, if you square a square root, what happens? You quote unquote get rid of the square root. All right, so we got the split over here. So we have on this side, we just have x over 32 equals, and then 1.618 squared is 2.617. All right. Now multiply both sides by 32. X equals 83.77 grams per mole. Okay. All right. So now I got to figure out. Now I got to figure out what type of atom this is. So it is a noble gas. So let's look at our periodic table here. And if we look here, I don't have any molar masses here. Okay, if we look here, krypton, if you look at the periodic table, krypton has a molar mass of 83.8 grams per mole. So 83.8 is closest to this, so it is krypton. All right. So yeah, so you have to look at periodic table with atomic masses. Unfortunately, this is the only periodic table I had, which doesn't have them. Yeah, you have to look on the periodic table, look up molar masses, and see which one's closest. Okay. Now, I had to be specific. Many different compounds can have the same molar mass. All right. So I have to be a little more specific. I can't just say what's the gas or what's the compound. You don't know unless I give you a little more detail. So here we said noble gas, so then you know you have to look in the right column. Okay. Right. So I'll try another one here. I'm gonna make this one up here. So let's say helium. Helium is 2.633 times faster than a certain diatomic element. Make sure I spell element right. Okay, so I say find this element. All right, so let's try that out. So helium. So if we do gas 1 and gas 2. Okay, well, helium's a lighter gas. See, it's that many times faster. So gas 1 we're going to say is helium. Gas 2, X. So R1 over R2. Mass 2, which is X. Mass 1, which is molar mass for helium, is 4.04 grams per mole. Should be looking up on a periodic table to make sure we're doing this right. All right, let's get rid of my equation here. Our rates are 2.633 over 1. So there we go. All right, now we're going to take a square root of both sides. Or square both sides. All right, so let's see. So that gives us 2.63. So on the right side, you get X over 4.04, and 2.633 squared is going to be 6.932. And solve for X. X equals 28 grams per mole. All right. So now, what element is it? Well, if you look and say, oh, the element's 20 grams, no, it's not that. Look up here. It said diatomic. Diatomic means 2 elements. Yes. So it's something like O2 or H2 or Cl2. So that means we need to take this and we're going to divide by 2. Right? Because you have 2 elements. So that gets you 14 grams per mole. All right, so now get your periodic table and look up what element, just a single element, has a mass of 14 grams per mole. Not 28, but 14. So we go back here. Okay, if you look up nitrogen, it's 14.01 grams per mole. All right, there you go. Yeah, silicon's about 28, but silicon's not diatomic. So you know it's not that. So it can't be that. It has to be diatomic. It has to be 14.01 because we divide by 2. So it is nitrogen, or N2. There you go. So that's how you calculate the Grahms Law of Diffusion equation, and how you find elements with that.